Hi friends, in this video we are going to take a numerical which will give you an application of KVL and KCL together. So let's have a numerical. So let's mark all the values to the elements. So I'll consider this as a battery of 10 volt, 20 and 30 volt. Let's give values to the resistance in an increasing order starting from 1. So I could have any random value. So let's start 1, 2, 3, 4, 5 and 6. Now I will apply KCL to node A, B, C and D such a way that I will get all branch currents. So let's take this as I1. Out of this I1, which is the incoming current for node A, I will consider some of the current is outgoing in this 2 ohm resistance. So obviously KCL at A, I will get I1 minus I2. Same will be the current flowing through the 3 ohm. So here I will mention I1 minus I2. Now I consider this current as I3 and KCL at point B will give me current flowing through this branch as I1 minus I2 minus I3. Same will be the current through this branch. So I will mention here it is I1 minus I2 minus I3. This current will be I2 and this current will be same I3, and KCL at C I will get current through 6 ohm as I2 plus I3. And finally if I apply KCL at D, I am getting this branch current is I1, which is same as the current flowing through the 1 ohm resistance. So I have done all current markings based on KCL at different nodes. So I'll write here by applying KCL at nodes A, B, C and D, all branch currents are marked, which will be our objective, meaning I may ask the question, find out the current flowing through the 1 ohm, 2 ohm, 3, 4, 5 or 6. So we will take only one of the outcomes. So I will consider, let's calculate what is the current flowing through the 2 ohm, and I have to apply KCL and KVL to get an answer. So I have applied a KCL and I have marked all branch currents. Based on this direction of currents, I will have the voltage drop across resistances. So in the direction of current, I will have voltage drops of the polarities which I have shown like this. So my circuit is ready. Remember, these three are the voltage sources, so it will not have the direction or say the polarity based on direction of current. It will be fixed, longer arm plus shorter arm minus. Now my circuit is ready for application of KVL. So let's apply KVL to loop 1, loop 2 and loop 3. Every time I am tracing a path in clockwise direction. So keeping this in mind, let's write the equation. So first let's apply KVL to loop 1. So I will get minus 1 I1 minus 2 I2 minus 6, current flowing through the 6 ohm is I2 plus I3, and potential difference for a battery is plus 10 equal to 0. Now I will simplify. I will get minus I1, minus 2I2, minus 6I2, minus 6I3. I am taking this constant to other side, so that will become minus 10. So finally I will get expression minus I1 minus 8I2 minus 6I3 equal to minus 10. This will be equation number 1. Similarly, I can apply KVL to loop number 2. So if I apply KVL to loop number 2, I will get minus 20 minus 3 I1 minus I2, current flowing through the 3 ohm, minus 4 I3 plus 2 I2 equal to 0. Let's simplify. So I will consider minus 20 as it is minus 3 I1 plus 3 I2 minus 4 I3 plus 2 I2 equal to 0. So let's club the like terms. So 3 I2, 2 I2 will become 5 I2, and let's take this constant minus 20 on another side of equation. So my equation will become minus 3 I1 plus 5 I2 minus 4 I3 equal to 20, equation number 2. Let's apply KVL to loop number 3 in a similar manner. So apply KVL to loop 3. So I will have 6 into I2 plus I3 plus 4 I3 minus 5 I1 minus I2 minus I3 and plus 30 equal to 0. See, all this plus minus we have considered as per the direction of current and whether it is having a voltage drop or voltage rise. In case of voltage drop, we consider the negative. In case of voltage rise, we consider positive. So let's simplify. I will take this plus 30 on another side of equation, which will become minus 30. Let's club all like terms. So here minus 5 will be alone. Then this 6 I2 and this 5 I2 will become 11 I2. 6 I3, 4 I3 and 5 I3 will give you 15 I3 equal to minus 30. This will be equation number 3. So I'll have 3 equations and 3 unknowns. Solving equation 1, 2 and 3, I will get answer I1 equals 3.3333 ampere. I2 is same 3.3333 ampere, and I3 I will get minus 3.3333 ampere. Minus means whatever direction of I3 we have assumed, that need to be reversed. That is the only thing. Otherwise the magnitude will remain same. Now our objective was to get a current flowing through the 2 ohm. So current flowing through the 2 ohm is I2, and we are getting answer for I2 is 3.3333 ohm. So finally I can write current flowing through the 2 ohm will be 3.3333 ampere. This way you can get current flowing through any of the branches by using a combination of I1, I2, I3. Meaning, suppose they are asking what is the current flowing through the 5 ohm. So simply I1 minus I2 minus I3, you have to put the values of I1, I2 and I3 whatever we got and get an answer. So similarly we can have current flowing through all the branches. So this way KVL and KCL together can be applied to a problem to get a current flowing through any of the branches given. We will see more numericals based on this KVL and KCL. It's a modification, we call that as a nodal and mesh in subsequent videos. Thank you.